Hello students, we will continue our lesson with the topic of eyeglasses. In this video, the lesson will be focused on the use of a concave lens as the negative lens for a nearsighted person. As we know, people use eyeglasses to make correction to their vision defect. There are 4 types of vision defect. The first one is nearsightedness or myopia. The second one is farsightedness or hyperopia. Another term for hyperopia is hypermetropia. The third one is presbyopia, and the last one is astigmatism. Most of vision defect happens due to the loss of power of accommodation. Power of accommodation is the ability of the eye lens to focus near and far objects clearly on the retina by adjusting its focal length. Now we will start our discussion about vision defect from myopia. Myopia is the inability to see distant objects clearly while close objects are clear. For our eyes to be able to see things clearly, the refracted rays must intersect or must be converged right on the retina. From the figure, we can see that the nearsighted or myopic eye converges rays from a distant object in front of the retina. Thus, they are diverging when they strike the retina, producing a blurry image. This can be caused by the lens of the eye being too powerful, or in other terms, the lens cannot do minimum accommodation. The lens of the eye is too thick, or the eye is too long, so that the distance from the lens to the retina becomes too far. In myopia condition, more divergent rays from a close object are converged on the retina for a clear image. Therefore, a nearsighted person can see close objects clearly. The distance to the farthest object that can be seen clearly is called the far point, also known as punctum remotum or PR of the eye. The value of PR for normal eye is infinity. Correction of nearsightedness requires a diverging lens that compensates for the over-convergence by the eye. On the figure, it is shown that the rays of light are first diverged by the concave lens. The red lines show that after the rays have been diverged, the eye is finally able to converge the refracted rays right on the retina. This will form a clear image. We don't realize that the concave lens plays a little trick to our eye. We cannot force the myopic eye to see distant objects clearly. Therefore, the diverging lens produces an image closer to the eye than the object, so that the nearsighted person can see it clearly. But don't worry, our brain is smart enough to know the real position of the object. Even though the concave lens produces a closer image, the object still appears far away from us. The image will be formed at the PR of the person. This This gives us the value of Si equals to negative PR. The negative sign in front of PR shows that the image produced by the concave lens is a virtual image, while the value of SO equals to infinity. Now we will try to do a work example together. But first, I ask you to please try it by yourself. We will discuss the result on the next video. So, that's it for now. See you.